Pi is a mathematical constant that represents the ratio of any circle's circumference to its diameter. Pi is commonly defined as the ratio of a circle's circumference c to its diameter d. Pi is non-negative, real and irrational number, meaning that its decimal representation will never end or repeat. Pi has been used for a variety of applications in mathematics, physics and engineering. Its value will have been calculated to trillions of digits over the next few years. That is to say, it cannot be considered as a ratio of two sensible numbers. Pi can sometimes be expressed as a fraction of 22/7, but that's just an approximation. It's about 3.14159 and can be applied in a lot of calculations. The value of pi is approximately 3.14, but it has an infinite number of decimal places. It is often rounded to 3.14 or 3.14159 for practical purposes. Pi is a universal constant, meaning that its value is the same regardless of the size of the circle. This means that if you know the diameter or radius of a circle, you can use pi to calculate its circumference and area, no matter how big or small it is. Pi is a mathematical concept that has been known and used for thousands of years, so it is not attributed to a single discoverer. However, the ancient Greek mathematician Archimedes is often credited with calculating an approximate value of pi using inscribed and circumscribed polygons around a circle in the 3rd century BC. Archimedes created a circle in which the diameter is 2, and the circumference was pi. He then placed two hexagons, one circumscribed within the circle, and the other with the circle circumscribed within it. He concluded that the larger perimeter of the surrounding polygon would be larger than pi, and the inner one would be less than pi. With this information, he claimed that pi was between 3 and 3.464. But he went farther than that. He wanted to be more precise, so he moved to polygons with more sides. He used 12, 24, 48, and finally a 96-sided polygon for searching the pi values. Around 265 AD, the Wei Kingdom mathematician Liu Wei created a polygon-based iterative algorithm and used it with a 3072-sided polygon to obtain a value of pi to 3.1416. In the 5th century AD, Chinese mathematicians approximated pi to 7 digits, while Indian mathematicians made a 5-digit approximation, both using geometrical techniques. Aryabhata of India discovered an approximation of pi, 62,832 20,000 equals 3.1416. Kelalar Nilakantha Somayaji, the 14th of June 1444 to 1545, also referred to as Kelalar Komadiri, 1, was a major mathematician and astronomer of the Kerala School of Astronomy and Mathematics. Around 1500 AD, a written description of an infinite series that could be used to compute pi was laid out in Sanskrit verse in Tantrasamgraha by Nilakantha Somayaji. The symbol pi was devised by British mathematician William Jones in 1706 to represent the ratio and was later popularized by Swiss mathematician Leonhard Euler. John Machen devised his formula for pi in 1706. It allowed him to calculate pi to over 100 decimal places. This greatly surpassed the work of Ludolf van Seulen. The basic idea of the Monte Carlo method for estimating pi is as follows. Imagine a square with side length 2, centered at the origin, and circumscribe a circle with radius 1 inside this square. The area of this circle is pi, since its radius is 1. Now, randomly generate a large number of points, x, y, that lie within the square, and count the number of points that also lie within the circle. The ratio of the number of points inside the circle to the total number of points generated is an estimate of the ratio of the area of the circle to the area of the square, which is pi, 4. The Leibniz formula is another way of calculating the value of pi. In mathematics, the Leibniz formula for pi, named after Gottfried Leibniz. Mr. Ramanujan discovered a formula for infinite series for pi in 1914, which is the basis of many algorithms that are used today. One of the most important challenges in mathematics history has been to find an accurate approximation for pi. This is from Ramanujan, who claimed the goddess of Namagiri appeared to him in a dream and told him the true value of pi. This curious approximation follows the observation that the 193rd power of 1 pi yields the sequence 1,122,211,125. An algorithm to calculate the number of digits is called Gauss-Legendre. Improved approximations to the circle constant are produced by successful algorithm variations. The algorithms derived from a mathematical understanding of arithmetic geometric mean, and it is distinguished for being significantly convergent, quadruplicationally, so that just 25 iterations produce 45 million correct digits. The Bailey-Borwein-Plouffe formula, BBP formula, is a formula for pi. It was discovered in 1995 by Simon Plouffe and is named after the authors of the article in which it was published, David H. Bailey, Peter Borwein, and Plouffe. A spigot algorithm is a type of algorithm used to compute the digits of a mathematical constant, such as pi or e, in a sequential manner, without needing to compute all of the preceding digits. In other words, spigot algorithms allow you to calculate a specific digit of a constant without having to calculate all of the digits that come before it. In other words, a spigot algorithm is an algorithm for computing the value of a transcendental number, such as pi or e, that generates the digits of the number sequentially from left to right, providing increasing precision as the algorithm proceeds. Spigot algorithms also aim to minimize the amount of intermediate storage required. The fastest method for computing pi nowadays depends on the specific requirements and constraints of the problem. For example, if you're interested in this, there's a big need to compute pi's number, digits of pi. Chudnovsky algorithm is generally considered to be one of the quickest ways to do it. This is a complicated matter, however. Algorithm that requires a significant amount of computational resources. For most numerical calculations involving pi, 39 digits are sufficient to perform most cosmological calculations, because that is the accuracy necessary to calculate the circumference of the observable universe with a precision of 1 atom. In cosmology, pi is used to calculate gravity, energy, and mass of celestial objects. Pi value is used in almost all the areas of science and technology like physics, electronics, electrical, mechanical, civil and medical sciences. A biochemist uses the pi values when studying DNA. Medicine benefits from pi values when a doctor studies structure of eyes and using lenses. People have worked hard to compute pi to thousands and millions of digits to break records. Uses of finding pi values to billions of digits have practical benefits in testing supercomputers, testing numerical analysis algorithms, and providing data for evaluating the randomness of the digits of pi. The most famous pi-related stories is the story of the Indiana legislature's attempt to pass a bill in 1897 that would have legally defined the value of pi as 3.2. According to the story, a physician and amateur mathematician named Edward J. Goodwin approached the Indiana legislature with a proposal to redefine the value of pi, arguing that the traditional value of 3.14159 was incorrect and that he had discovered a new mathematical formula that would yield a more accurate value of pi as 3.2. Goodwin's proposal was met with skepticism by most mathematicians and scientists, but he was able to convince a few legislators to introduce a bill that would have legally defined pi as 3.2. The bill was debated in the Indiana House of Representatives and actually passed by a vote of 67-0. However, when the bill was sent to the Indiana Senate for approval, it was met with ridicule and criticism from mathematicians and scientists across the country. The bill was eventually tabled and never became law. Pi Day is global celebration mathematical constant pi pi, observed annually on March 14th, especially in countries that use the MDD, YYYY date format. The tradition was founded in 1988 by physicist Larry Shaw, who chose the date because it represents the first 3 digits of pi, 3.14. In conclusion, pi is a fascinating and enigmatic number that has fascinated both mathematicians and non-mathematicians for millennia. Pi has been a significant factor in many academic disciplines of study, from prehistoric civilizations to contemporary technology. Its irrational and endless features continue to stump mathematicians and spur fresh research. We learn more about the universe's underlying principles and the allure of mathematics as we delve deeper into the secrets of pi.